record. Okay, sir, you are able to see this. Basically, what you have to see here is you take, see, for cable damage curve, you need not ask the vendor. Okay, for cable damage curve, just take the data that you get from any vendor catalog. When I say you need not ask the vendor, you need not specifically ask for any test report or anything. Vendor catalogs usually will have this one, the short circuit rating for 1 second. Okay, suppose the short circuit rating is 50 kA for 1 second, not 50 K, sorry, for a 50 square mm cable. For okay, let me take this. For a 50 square mm cable, the short circuit rating for a copper conductor is 7.15 kA. In other words, I can pass 7 kA without causing damage. Okay. And if it is aluminum cable, it is 4.7 kA. Okay. Now, if the voltage level changes, this is a low voltage cable, the cable is a HV cable, the short circuit rating will slightly change. So you have, based on the rating of the cable, voltage, type of insulation, please get the short circuit rating from the vendor catalog. PVC cable, XLP cable, all these cables have different short circuit ratings, you can get it. And once you get the current, no, I will tell you how to plot it. I will show you how we plot it in the Excel. Okay. This curve, what given in the right side, whatever vendor has given, I have just taken it. Okay. But when we do our plot, let us plot current in the y-axis and time in the x-axis. Okay. So when you are doing your relay coordination, basically, particularly when you're doing the feeder protection. See, what are the things we are going to protect in our, let me go back to this slide. See, what are the things? Suppose I have a relay, this breaker, if I have to do coordination, I have to do between this breaker and this breaker. That time, these two together will come as one TCC. That I'll explain you later. In that one TCC curve, we will have the damage curve of this transformer. We will have the damage curve of whether it's a bus duct or a cable here. We will have the damage curve of this cable. Okay. So these three items will be there along with the both these breaker curves. Okay. So 5 curves will be there. Suppose I want to, now next is I will coordinate this particular feeder and this feeder. And that time what all should be there? This transformer damage curve, this cable damage curve, and here a cable or a bus duct damage curve has to be there. Then both these breaker curves has to be there. And one more thing, the motor starting curves have to be there and motor damage curve has to be there. So 7 curves will come in this TCC. Okay. And now these two are, now this one and this is also 400 kilowatts. So I need not plot this TCC. And this one is a lower rating, I can leave it. Now this transfer, this feeder and this feeder, yes. I have to coordinate. So here I will have transformer 1 and 2, cable 1 and 2, breaker 1 and 2, and one load here also the time. So totally this switch gear, somebody will tell me do the relay coordination. For this switch gear itself, I will have how many? 1, 2, 3. 3 curves I will have. I will have 3 curves I will have in this switch gear, and each TCC, each of these curves again inside them they will have 7 curves. So you see the amount of time it takes place. So this is one panel. If I go to a sugar plant, or an oil and gas, a steel plant, there will be some 100 plus switchgear or 200 switchgear. So I have to coordinate all the switchgear, and in each switchgear I have to choose 2 to 3 paths. Okay, so see the amount of time, and that is the reason we need software, ETAP or SKM. So you may ask me, when we can do in Excel, why do we need a software? See, the reason we are doing in Excel is to learn the basics. Keep that clear in your mind, right? Okay, it is for learning purpose. But when we actually do a big plant, we have to depend on a software. Why we have to depend on a software? I have explained to you just now. Any doubt on that?
Sir, one doubt, sir.
Yes, sir.
You told on that slide just now you are showing the protection slide.
Yeah.
Coordination, the XLD you are shown, sir.
Yeah.
Yeah. Sir, here actually for even though this motor ratings are same,
Yeah.
based on cable length, this short circuit will vary, sir. So
Based
setting
on-
may slightly vary.
Yeah, correct. If the length of the cable is different, the short circuit current will be different and the setting will be different. You are correct. And we have to then plot the curve for that also. You are correct, perfectly correct. Suppose if my length of this cable is 300 meter and since both of them are 400 kilowatt, since this is 300 meters, you are correct. The length of the cable is more, the short circuit current has reduced. So I have to plot this also and I have to generate the setting. You are exactly correct because the setting has to be generated individually for each relays. Correct, sir?
Excuse me, sir.
Yes, sir.
For the switchgear event transformer, we usually specify the short circuit MVA or short circuit rated current for a particular duration, say 2 seconds or 3 seconds.
Okay.
That means that particular requirement, it has to be withstand for 2 seconds or 3 seconds. Then why do we need again to study this damage curve? Because relay is supposed to send the trip signal within and breaker will trip within 50 to 60 millisecond or even 80 millisecond. Then why do we need to study this one?
Sir, when you will see if my part is, let's say 4 kA, 5 kA, I will trip in, let's say 300 millisecond or 400. That depends on the curve, okay? Right now, I'm just giving a figure. But let's say fault is, what is this motor? 400 kilowatt motor, right? 400 kilowatt, 6.6 kV. What is the load current? Please check. I have written some value. You can also check. What will be the load current? 400 kilowatt, 6.6 kV. How much, sir? Anybody checking?
Is it three phase?
Yeah, 3-phase. 400 kilowatt.
34 ampere.
How much?
34.
34. Huh? Okay. Now,
Sir, it's 34 amps without power factor of 0.8 or 43 amps with power factor of 0.8.
okay, let me take power factor. I will take 40. Let's take 43 amps. Now, 43 amps. Okay, Mr. Inamul, I will answer your question. If 88 amps flows, okay, do you want my relay to trip in 300 millisecond? If 5 kA flows, I will trip in 300 millisecond. If 88 amps flows, it is a lesser current. Can I not allow my feeder for a longer duration? So you are the answer for your question is very simple. The current at lower values will take more time. Okay, it is that millisecond what you told is for a very high current, but there are current which are very close to the load also. No? Those currents will take long time. That is well understood, sir.
Then why we are increasing the cost of the switch gear by mentioning say 3 seconds? Then we can mention our specification in 1 second.
No. See, it is like this. The switchgear will undergo a 25 kA fault also. It may undergo. It may get overloaded for 2 times the current also. Let's say I have a 2500 amp switchgear. There is an outgoing feeder, let's say of the 630 amps. That particular feeder may see 1000 amps also, and due to a fault it may see 25 kA also. Okay, so the reason why I'm giving that 1 second, 3 second is okay. I am telling 25 kA for 3 seconds or 25 kA for 1 second. 25 kA for 1 second is like something like, let's say 1000 seconds, 1 kA, something like that. Okay, I square T 25 is 625, 625 into 1, so it is 625 kA, 625 into 1, so if it is 1 kA, it is 625 seconds. So what I'm telling, Mr. Inamul, your question is why am I going for 3 seconds? That is basically I square T. You don't see I and T alone. When you start doing this relay coordination curve generation in the next class, you will understand. We are talking about I square T. So I into T. So if my switchgear can tolerate 25 kA for 1 second, I square T rating is 25 square into 1, which is 625. And since I square T is 625, for if the fault current is 1 kA, my switchgear can tolerate it for 625 seconds. Okay, so at lower fault current or overload, my switchgear can tolerate it for a longer time. At higher currents, it can tolerate for a lower time. The reason why we are giving this particular time and current is based on the I square T rating. That we will gradually come to know. Okay. Okay. So now, what is the time now? Okay, we will just do for another 5 minutes, and then the motor damage curve we can take in the next class. Now I will just draw and the board and I will explain that. Do you want to cover the motor damage curve today or in the next class?
Next class, sir, because need to understand it deeply.
Okay. So now let me actually, I will write in the board and I'll try to explain some more things, whatever we did today. Tomorrow we will talk about the next, tomorrow means next Saturday, we'll talk about this motor damage curve. And that time actually I will show you some reference material from GE and ETAN. After the class, see whatever material I'm giving you, the links, please go through them, so that we can discuss that also. It is a lot of nice material I will share you, G and E10 in the next class. Okay. So after more.
Sir,
Yes, sir.
Sir, will we be doing the building up the curves and doing the trip setting also in Excel as the part of the exercise?
Yes. See, I will tell you what all we'll do. Yeah. We will first, next class we'll cover motor damage curve. After that, we will cover motor starting curves. Okay. In the motor starting curve, okay, I will teach you also how to estimate the starting time based on the load inertia. Okay. And I will give you the reference
sir.
also. Then we will talk about transformer inrush currents. And then we will go to the type of TCC curve, okay? All different types of curve. And after type of TCC curve, okay, I will teach you how we will do the plotting in Excel. Okay.
sir.
Then we will
So- yes,
take,
sir.
then we'll go to sequence network, how to do positive, negative, zero sum calculation. Then like that, full complete setting, everything I'll teach. Okay.
Okay, sir. Very nice. Yes, sir. Funny, sir, one more thing. In this motor starting, will you be including this hot starts, cold starts?
That, see, hot start, cold start, the thing, there is a limitation when I will tell you theoretically, but when we are adding the curves here, what happens is, see, creating a curve in Excel is not difficult. We can get, but if we have to get the data, that is a problem. Vendor getting the guys who have prepared suppose we are doing coordination for, let's say, 15 or 20 megawatt motor or a 5 megawatt motor, a big motor, not like a synchronous motor or a big induction motor, you will get the curves, no problem. But you are doing coordination for a 200 kilowatt motor, 132 kilowatt motor, getting curves is very difficult. Vendor will not give you. At that time you have to assume and you have to use the curve which is present in the software. So software will give you hot and cold everything. But when we are doing in Excel,
Okay, sir.
for us there is a limitation.
Okay, sir.
We cannot get all the data because software guy, he has got the data from a long time with an understanding. Okay. So suppose you get a hot start and cold start curve, then we will surely do that. Okay.
Okay, sir. I'll try to get something, sir. I have some vendor data. Let me try to get something.
Okay, sure. Whatever. See, when we are doing the relay coordination, initially one example I will do what I have. Later on, you can get your examples. We will work out together in the program. Okay. Mr.
Okay, sir.
Krishna Kumar also was telling that he wants to work on some practical this one. So you can get your cases. We will together do it. Okay.
Okay, sir.
Yeah, so let me actually stop the screen share. And,
Yes, sir.
I will just write in the board and quickly. Able to see?
Yes, sir.
Yes, sir.
Yeah. Whatever we have covered today, and maybe the voice may be little feeble, kindly bear with that. So quickly cover whatever we have spoken today. Yeah? So what all we covered today? Can you please tell me so that I will write down?
Transformer damage.
Okay. Transformer. Transformer damage curve, right? Transformer damage curve. We have a table, right? Like 2 times current. 1800 second. So basically what you have to do is you have to, is the screen visible?
Sir, screen is visible.
Okay.
Yes, sir.
So basically this, you will have these things, you get it from, let's say, ANSI. Okay, you get it for right whether your transformer is dry or oil, you get this curve. Once you get this curve, basically what you have to do is you have to plot the time versus current. You have to plot it like this. And what you will see is in a transformer itself, you will have three curves, right? One is you have the damage curve, and one is you have your inrush. Okay, in the damage itself, you have the thermal damage, and then you have the mechanical damage. Normally, in any this one, the top portion is dominated by the thermal, and the bottom portion is mechanical. Okay, but usually we get only the thermal curves. Mechanical, if anybody else will get it, you can share it. Okay, so that was what and this inrush current, I will explain this in the next class. Okay, now small transformers, you please refer the standard. Big transformer, please get data from the vendor. Okay. Okay. And one of you asked ONAN, okay. Vendor, if you are buying a ONA transformer, see the transformer may normally air, and then it will turn on the fan later on. So that time what will happen, if you see the transformer will have three ratings, right? Suppose I go for a 100 MVA transformer, ONAN rating, ONAN is 130 MVA. So how do I plot my relay coordination curve? For this, it is a question for you. Please write down. ONAN rating is 100 MVA. And ONAF rating is 130 MVA. Okay, plot the damage curve. Okay, this is a exercise for you. Okay, now okay, that's about the transformer. Then let me go to my, which is the other one I did. Which is the other one, sir? Which is the other one? You're able to hear?
Cable damage curves, sir. Cable damage curves. That's
Cable.
what we discussed.
Motor we didn't cover, right?
Motor we did not discuss too.
Okay, cable. So, in case of cable, it's really simple. There is no mechanical in cable. Cable is purely thermal. See, cable is purely thermal. Your transformer is thermal and also mechanical. Okay, in case of your motor and generator, it is thermal, mechanical, then again stator, rotor. So you see the damage, this one, if you see this, you make a small observation. Okay. For cable, the damage is only thermal. For transformer, it is thermal and mechanical. For motors and generators, it is thermal, mechanical, along with stator and rotor. So when we draw the curves, we have to take care of it. Now, cable damage. Pardon, sir?
What are the last two entries in generator and motors? Last two entries besides thermal and mechanical.
This is stator, rotor.
Okay.
Sir, in the transformer, do we have two different curves, one for the primary side and one for the secondary side, or it's just one curve we'll have for every transformer?
No, sir. For me, transformer is basically like a pipe for me, carrying power. Okay. I am not bothered primary, secondary. When transformer is loaded, primary and secondary works together.
Okay, sir.
Both of them work together, primary and secondary. So we will not really bother about that. Okay, sir.
No, but then the SKM site is saying that there'll be two sets of curves, one for the primary and one for the secondary. That's why I asked.
You do one. See, you check with any vendor. Okay. As far as I know, transformer damage curve, there is nothing like primary and secondary.
Can I share my screen, sir? Briefly, may I just share my screen?
Yeah, sure, you can share.
Oh, I don't have, so you have disabled it, sir. So,
I have not disabled actually. This is not giving the. I have noticed it.
oh, the host has disabled it. Maybe is it possible I can upload it in this chat?
Yeah, sure. You can upload in the chat. Sir. You can upload in the chat.
We just try. I'm just going to make an
Actually,
attempt.
what we'll do, we are running out of time. You upload in the chat in the next class. We will check it. Okay, sir. Is that okay?
Yes, sir. It's not allowing me to do that, so it's got some.
You do one thing, Pinaki. You
Yes, sir.
upload in that WhatsApp message. Okay, what we'll do.
Okay, sir. Fine.
We will check it in the next class for sure.
Okay, sir. I'll do that, sir.
Huh? Yeah. Because I want to wind up now. It's already.
Yes, sir. Sure, sir. Sure.
So the cable thermal damage curve basically depends on the I square T rating. Okay. Suppose I have a 50 square mm cable, copper cable. The short circuit current is 7 kA for 1 second, right? So what is the I square T rating? 7 square into 1, that is 49. Okay, so if I plot the I square T rating, I will get a curve on it. So for a cable, it is very simple. Okay. So today I have talked about the damage curve, the motor and generator damage curve. I will take up in the next class. Then the inrush curve I will take up in the next class. Okay. Okay, sir. Thank you, sir. Thank you very much. Any doubts?
Funny, sir. Can I just continue with you for 2 minutes because this YouTube video still it is not working for me, sir.
No, YouTube. What you do, you try to log out and try some other device because.
So I've tried my laptop.
Okay, sir. I will do one thing. Let me go and check once again I will check once again.
Yes, sir. See, the message I'm getting is video unavailable. This video is private. Go to home.
Okay,
that's all.
Okay, sir. Give me time. After this class, I will check again whether.
Yes, sir.
I've
signed out of my account. I've signed back in also. I've tried
once again share this email ID, sir. Again, I will add it freshly. Okay.
Okay, sir. Fine, sir. Again, I will share.
The WhatsApp you share. Again, I will add it. Okay.
Yes, sir. Sure, sir.
Okay, sir. Shall we wind up for today?
Yes, sir. Thank you.
So, thank you, sir. Thank you, everybody. Take care.
Thank you. Happy Sunday. Happy weekend, everyone.
Thank you.
The first session, you have shared some link. So can you share that link in WhatsApp, sir? So you have shared one link, sir, in first session, today's first session.
Oh, I will share in WhatsApp, huh? Oh, hold on.
No, you shared here only, so you can share in WhatsApp, sir, so we can take it.
I will share which link. SKM, this SKM link, right?
No. ABB web link.
ABB, okay, ABB release. ABB trip.
And ABB for that electronic trip units, and SKM also is shared, sir, that for one reference.
Okay, I've shared the ABB electronic trip unit, those things you can have. I've shared in the WhatsApp group. Okay, sir.
Sir, is
Okay.
SKM software, sir, is it an expensive kind of a software? Is it something?
All your software, SKM, your ETAP, your Paladin, Sime, all of them starts at minimum 10-15 lakhs.
Oh,
All of them are
okay, sir.
costly. And
Oh, ETAP, I know, sir. It's like a very
and
expensive.
actually,
I thought maybe
Paladin had
SKM.
monthly cloud license. It was very nice option. And I don't know, somehow somebody purchased that company last month. Earlier it was $250 per month. That was okay. Whenever we are doing something, we could have rented it out. But those fellows also stopped that option. But I'm sure you just another 1 year, you will see a lot of change in the power market. See, AutoCAD has come now with your monthly license. Adobe has come with a monthly cloud license. So future will be cloud license. Nobody will buy software perpetually. So you will see in future that all these softwares will be available on a monthly basis. So don't